All right, everybody. Well, it's 3 o'clock here in sunny California. I don't know where you're calling in from, but we are here today with Mortenson and Built Robotics. Thank you for joining this ACE venture. I am going to go ahead and turn it over. So thank you for joining. Remember to keep yourself on mute. If you have any questions at all, please put them into the chat and we will get to them throughout the program. Again, thank you for joining and welcome Mortenson and Built. Thank you.
Well, that looks like we got quite the turnout here, roughly 25, 27 people, and I think there'll be some more kind of filling in, but welcome everybody. We appreciate everybody taking the time out of their day to come chat with us about some construction and some robotics. I know the Mortenson and Built Robotics teams are super excited, and we wish we could do this in person, but I think we're gonna have a little bit of fun. And I think the first thing before we get into introductions, we wanted to start off with a quick video just to give everybody kind of an idea of what we're going to be talking about today. So with no further ado, here we go. So that's pretty cool, isn't it? That video was taken on one of our job sites in Kansas, and we'll get more into kind of how that took place, kind of how the equipment works, and a little bit more about renewable energy in the wind and solar fields. But we'll jump right into introductions, and I'll pass it over to Eric.
Hey, thanks, Derek. And my name's Eric Stellman, and I work with Derek in the civil group at Mortenson. The civil business is one of 15 operating groups at Mortenson, which collectively comprise about $5 billion a year in revenue, which puts us as one of the largest contractors in the country. Probably ENR top 15, top 20 sort of a contractor. And I think one of the reasons for that we've had a lot of success is we're very diverse, and so some of those operating groups really concentrate in a region, and they build buildings, hospitals, office buildings, kind of your traditional vertical construction just in their region. And some of our regional offices are Minneapolis and Denver and Seattle and Portland and Phoenix and Chicago, and they're kind of like traditional construction companies. And then the civil group is one of the, the national, very industry specific groups, which we go all across the country regardless, of region. And we've just focused on our area of expertise. There's a wind group that is like that, a solar group, a civil group, a power group, and then also a group, that concentrates on sports facilities, and one that does federal contract. And the sports group is probably our most famous thing. We've just have completed the Chase Center in San Francisco where the Golden State Warriors play, and also the new Raider Stadium in Las Vegas. So those are big high profile jobs, but I think it's that diversity that has kind of led to Mortenson's success. And so the civil group that Derek and I are in, we focus really on heavy civil infrastructure all around the country. A lot of it And by heavy civil infrastructure, I mean roads and bridges and earth moving and site development, water resources, not buildings, not buildings. But the idea with that kind of work is we're really trying to advance the state of the art in terms of technology and look for new ways to kind of engage with advanced technology. So we're really excited about our partnership with Built Robotics. Before I did that, I worked at a heavy highway company in Minnesota and really learned about the business. I did jobs like starting from foreman, and I went up to field engineer and project manager and chief estimator, and I really learned the business there before I joined Mortenson in '08. And prior to that, like by education, I went to University of Minnesota, got my civil engineering degree from University of Minnesota, and more importantly, met my wife of 25 years in my freshman year fall quarter at the U of M. So that's my story. And now, Derek, maybe you tell a little about yourself.
Hey everybody, I'm Derek Smith. I'm the Lean Innovation Manager in the Civil Group. What my position kind of does is all things technology, all things equipment, all things software. That's my main focus is looking out, seeing what's coming next in the technology field, whether it's a new app, a new piece of software, or it's an autonomous equipment like we're going to talk about today. One of the things that we've also worked in is if anybody's seen the Boston Dynamics robot dog, we do have one of those, and we have playing around with one of those, and it is pretty awesome. But my background is I've been with Mortenson about 7 years. I've worked in our IT department on rolling out different software applications to our project sites and our operations. And then before that, I worked at Target and Wells Fargo, so a couple different industries. So at Mortenson, this is my first job in construction. And I went to the University of Minnesota, or the University of St. Thomas in Minnesota, and I graduated with a degree in entrepreneurship. And with that, I'm going to pass it over to the Built Robotics team, and they can go give their introductions.
Thank you, Derek. Hey everyone, thanks for joining today. My name is Gaurav Kikani, and I'm Vice President at Built Robotics. I'll give you a quick background on Built. I think that video kind of does a good job of articulating what we do, but our goal is to actually automate heavy equipment. So how do you take a bulldozer, an excavator, and build the technology that'll help it make decisions on its own, sort of the way a human does when they're sitting in the cab, moving the joysticks and making decisions as well. And so what we're focused on really is a little bit of hardware. So there's like a kit that we apply to the machine to give it the senses and the ability to understand its environment. But then the real core technology is the software that we're developing. So we've been around since 2016. So this will be our 5th year. We're based in San Francisco, and our team is about 25 people. So we're not huge, but we've come a long way. And so my background is, so what I do at Built is I focus on the operations, finance, helping build the business side of the company, working with great partners like Mortenson to take these robots, put them in the wild, and see what they can do. And so I've gotten to know Eric and Derek over the last 2 or 3 years now, and we've come a long way together, and that's been a lot of fun. Before Built, I was actually not in construction. I was actually working in startups and in finance, so helping launch other companies out in New York. I helped start 2 companies there. And before that, I was actually in consulting. And so working with large businesses on the problems or the challenges that they have and helping them solve those problems. So one of the things that I used to do was in mining. Actually, one of my clients was in mining. And so I spent a lot of time on mine sites. And that was the first time I really got to understand, how much hard work goes into the heavy earth moving industries. And I credit that a lot for finding my way to Built ultimately and loving what I do here. And then as far as my educational background, I went to Northwestern University out in Chicago. I studied economics and math over there. So not really exactly what I'm doing now, but I think, it helped me learn how to think and be, logical and be a problem solver. And I use a lot of those skills even today. And then I grew up in Texas. So even though I live in California now, I grew up in Houston. My dad's in the oil and gas industry. So, I got to see a little bit of that side of things too, growing up. And then I had the pleasure of working with Jimmy, who's here too. So I'll hand it over to Jimmy to introduce himself.
Cool. Thanks, Gaurav, and thanks everyone also for joining. Yeah, a little bit about me. So I work on the business operations team with Gaurav. So, sort of like he mentioned, work together with him to, run sort of everything that entails the business side of our company. And a big part of that is working and identifying partnerships with great construction companies like Mortenson to find opportunities to deploy our robots and making sure they're sort of on the right projects, doing the right work. So yeah, it's been really exciting getting to know the Mortenson team, and we're really looking forward to continuing to build out our partnership with them. A little bit about my background. So a little bit similar to Gar, previous to Build, I wasn't working construction. I was working at a large consulting firm, working mostly with a lot of technology companies and a lot of retail companies to help them sort of solve some strategic issues that they've had coming up. And before consulting, I went to school at Washington University in St. Louis, studying finance and economics.
Perfect. Thanks, Jimmy. So here's the agenda for today. We'll kind of run through an overview of what the construction industry looks like in terms of how the adoption of technology has been over the many years, and the Mortenson Built Robotic Partnership, an outline of renewable energy projects. That's going to be the main focus today. We're going to be talking about deployment of these autonomous robots on wind and solar jobs, how the robots work, and then we have a couple more videos on how the software works with the robots, and then also kind of a live feed into what it looks like when it's actually in operation. And then we'll go into some potential careers that are related to and how the robotics industry kind of impacts the construction industry. But before we do that, we also do from the Mortenson side have Ariel Dorsey with us. She's on our marketing team, and she's going to be monitoring the chat. I see, Colin, that you've asked a question around the Built Robotics. Is it they have stock construction equipment and they add their modifications? We'll get into that later on into the presentation, but that is correct. And if people do have questions as we go through, feel free to put them in the chat. As we close out slides, we'll give a little bit of a pause just between slides, just in case there are any questions, so we can kind of stay with that topic that we just talked about. So with that, we'll jump right in. So this graph right here, it's a graph on what the construction industry likes in terms of the adoption of technology. So what you're looking at here is you see a couple different lines on the chart. You see architecture, manufacturing, and overall economic growth. And then the construction is at the bottom. What this shows you is the value created per dollar of labor. So what that means is how much production are we getting per dollar of labor that we're spending on specific activities. And one of the reasons why the construction is on the decline is as labor rates are historically going up, the way that the construction industry has worked has been very much the same. The adoption of technology over the last many years has not happened, and we're continuing to do work the same way that we've always done work. And with the labor rates going up, it's kind of impacting that trend for us. But that's very much changing. From 2015 to 2019, there's been a huge influx of investments into the technology industry. $5.1 billion has been spent in startups or other software companies to start to develop new tools and new applications to make the processes better. And as of recent, in 2020, about $1.3 billion was spent. And the focus has kind of shifted from some of those software applications to more artificial intelligence, robotics, like we're going to talk about today, and other emerging technologies. So before we jump into the next slide, any questions? And right now, it is a really exciting time for the construction industry because of this huge influx in new startups. new investments into developing new tools, and it's really changing how we're going to work and the future of how we're going to work. So with that, we'll go on to the next slide, talking about the current industry and kind of what it looks like. As you can see down there at the bottom, right now this is unprecedented demand for construction, and with that has created many opportunities for people to enter the industry, not in just performing the work to build the jobs, but also building some of the tools or some of the applications to help the builders build the jobs. Right now, 80% of contractors have a hard time filling trade positions. If you look at there's a backlog of about $2 trillion in infrastructure program that needs to happen. There's not enough builders and enough people to be able to meet that demand. And there's a shortfall of housing of about 7.3 million. Okay. So what does that mean for Mortenson and Built Robotics? This is the reason why we joined our partnership together. Mortenson, the jobs that we're going to be talking about today in our civil group is our wind and solar projects. And our wind and solar farms, if anybody's driven around the country, you're not going to see a lot of these in major metropolitan areas. These are mostly in very remote areas around the country that could be many hours away from the largest city hub. And it is sometimes a hard time for us to be able to find enough operators to be able to perform some of the tasks. So with this, if you're looking at this picture right here, one of the things we focus on is being able to put these robots on tasks that are very repetitive, very simple, where we can have our more skilled operators focus on tasks that involve a little bit more art, a little bit more eye, and a little bit more skill. So right here, this hole that you see down in the bottom in this picture is a wind turbine foundation. So what that is when you're looking at a wind farm, you're going to see a big wind turbine standing up. It could be 300 feet tall. So at the bottom of the wind turbine, we have to build a base so that it doesn't tip over. So this hole right here was fully dug autonomously by this excavator, and it is about 55 feet in diameter and about 10 feet deep. And then if you see the two ramps there, one of the ramps is for pedestrians to walk down, and the other one is for equipment to get down. So the reason we do this is we dig this hole, and then our wind partners will come in and put in steel rebar and concrete, and then we'll fill in the dirt back over that rebar and concrete so that we are able to stabilize that foundation and we can build that wind tower up. And then one of the other factors is productivity and safety on job sites. You think about it, a robot could theoretically work 24 hours a day, 7 days a week, as long as it has fuel, and as long as it has gas and someone's monitoring it. We're able to then leverage our operator skill where they could be managing potentially multiple robots, and we could be able to perform the same productivity or more to be able to continue to build that job site. And then we also take that operator out of harm's way so they're not in that piece of equipment, so the risk of being injured goes down. So I'll take a pause real quick. I know that was a lot of information. Feel free to put any questions in the chat. Perfect. So, and if questions do come through, we can go ahead and answer them, and we can go back to previous slides. So feel free to populate them into that chat. But we're talking here about renewable energy and the benefits around renewable energy projects. Like we talked about before, our main focus is on wind and solar. And here's some of the benefits that wind and solar bring to the table. It's a clean energy source. So as carbon-free, wind and solar can help reduce the world's dependence on fossil fuels, such as coal, oil, and natural gas. It's very sustainable. So as long as the sun is shining and the wind is blowing, we're going to be able to generate power. And kind of a fun fact for you is that wind is actually a form of solar energy. Winds are caused by heating the atmosphere by the sun, the rotation of the earth, and then the earth's surface irregularities. And it looks like we do have a question there. So Cobb asked, how do you predict autonomous heavy equipment will affect the job market? So with that, being able to, we don't look at these autonomous equipment coming in and replacing or operators. We look at it as giving our operators another tool in their toolbox to be able to build that project. So it'll allow the market to build more jobs. It'll allow us to get ahead of the curve in terms of the backlog of potential jobs there in the future. And then kind of like we have right here where it creates jobs, by 2050, it is expected that there'll be up to 20 million jobs in the solar market and 600,000 jobs into the wind market. And if you're looking at the local careers and kind of like the job increases over the next 50 years, renewable energy is going to be your highest demand.
Hey, Derek, we have a question from Jose. I think it pertains to the last slide. He's wondering how long would it take if a person did the work to build that, I think the turbine foundation?
Yeah, that's a great question. So a lot of it depends on the size of the excavator and then how big the foundation is. The foundations of the wind turbines vary in size depending on how big the tower is. But in general, it takes our operators roughly 4 to 6 hours to dig a hole or to dig that foundation. The robots that we've had, we've been able to do it in about 10 hours.
We have a question from Iris. They're wondering, do you guys deal a lot with ergonomics?
Oops, sorry. So that's a great question. So if an operator is in a piece of equipment, and if anybody's ever been in a piece of equipment, it can take a huge toll on your body when it's, because we're moving earth, we could be moving rock, we could be moving any other type of material, and it can take a toll on the operator's body. So one of the benefits and the safety benefits of using robots, where we could have that operator managing that piece of equipment while they're not in that piece of equipment, is it doesn't take a toll on their body. That's a great question. Okay. So here's a project spotlight, kind of like we saw in the video. That was a wind project that we saw those pieces of equipment operating. What you saw there was an excavator, a dozer, and a skid steer. At one of our most recent projects, we had a wind project in Colorado. It was about 3 hours away from the biggest city. And when we think about these wind and these solar jobs, the amount of land that these projects cover is enormous. This project right here with 229 wind turbines that we set up covered 155 square miles. That's a lot of land. It's able to generate 500 megawatts, which is able to power 270,000 homes. And out of those 229 wind turbine foundations that we had to dig to be able to erect the turbines, we dug 21 of them fully autonomously using the Built Robotics platform and their excavators. The next project spotlight. So this is a future job of ours out in California. It's just over 1,100 megawatts, is able to power about 260,000 homes. The size of this project is 7,000 acres, and we're going to be installing 2.5 million solar panels. That is a lot of solar panels. And when we saw in the video, we saw that excavator digging a foundation. On a solar project, we don't dig foundations. We have no need to dig that big of a hole in the earth. But what we do have to do is we have to build trenches so that we can lay the wiring to be able to connect all the solar panels together so that we can have a delivery system for that power. So on a job like this, where we have 2.5 million solar panels, we're going to have to dig hundreds of thousands of linear feet of trench. And that is something that sits up very well for a simple task for a robot to be able to do, because you're digging straight lines. So feel free to ask any questions on wind or solar or any of these past and future projects, and then we'll just jump right into how the robots work, and I'll pass it over to Jimmy.
Great, thanks, Derek. So yeah, what we'd love to do now is take the opportunity to tell you all a little bit about how our robots work. So essentially, how do we make them operate autonomously? A little bit about the safety system, because of course, that's a very important thing to think about as we develop new technology, is making sure we develop them to operate safely and make sure, you know, we manage any safety risks once they're deployed out to the field. And then we'll talk a little bit about what the role of the robot is. And I think that'll be a great time to discuss in a little bit more depth the question about, you know, how do we think robots impact people and sort of people's jobs currently. And then we've got a great little demonstration or a great little video for you all today where we'll show you what's it look like if you're the person giving the robot instructions. So obviously the robot works autonomously, but we need people to give the robot, you know, the instructions for what work to do that day and where to do the work. And we do that with a computer. So we'll show you a screen video showing you what that would look like if you were that person. And then a very sort of on the ground first person view of what does it look like when you're looking at the robot once it started working. So we'll go through all of that now. Again, please feel free to ask any questions along the way. But right now we'll start with a little bit of an overview of our robots and how we make that work. I guess this is a great time maybe to pause briefly and get to Colin's question from a few minutes ago, where he asked, so the built robots are mostly stock construction equipment with modifications to add autonomous capabilities. And yeah, that's generally right. That's of course, there's a million different ways to build robots, but our approach as a company is not to build everything for the robot from the ground up. But we know out there already, there's lots of great companies building really robust, really effective construction equipment. And so our role as a company is not to build that machine in and of itself, but merely to upgrade that existing machinery with technology components that we essentially attach and wire in and connect to that robot. And then we develop on the back end the software, which is what makes the robot intelligent and what allows us to control and give that robot instruction. So that's exactly right. And so if we dig into that a little bit, the way you can think about it on the hardware side, essentially it's a marriage between traditional construction heavy equipment and then some more innovative technology equipment, which is, you know, what we install onto the machinery. And really the idea here, sort of like Gaurav mentioned earlier, is how do we give the robot senses? Because the way you typically would operate a machine like the one you're seeing in this video is someone would sit in it, and once you get inside that cab that you see there are joysticks and there's pedals and there's switches, which is what you would use. And of course, as people, we have a brain, we have eyes, we have hands, and that's how we control it. So when we take the person out of it and we want the robot to work on its own, or in other words, work autonomously, we need to give that robot those same capabilities, right? And so we install a couple of things. One is a computer that we install on board. So the same way our brains inside of our heads work as our computers, we put a computer on for the machine. And then the same way we have eyes and senses, we put in sensors and cameras and other things which serve as the eyes and the senses of the robot. And so that's essentially how we upgrade the machine from something that has to be operated by a person to something that it can operate itself. And then on the back end, like we mentioned, the software is really the important part of making this all work. And you can think of this as the software for us to engage with the robot and the software that makes the robot smart. And so in terms of us engaging as people engaging with the robot, we have a vehicle interface, which is what we'll see in the video a little bit later, which is how we access the robot using a computer program to give the robot instructions and to monitor the robot while it's working. And then in terms of making the robot smarter, of course, there's a lot of things that we develop at our company to do this. But a couple of really exciting things are artificial intelligence for perception. So that might be a term that you guys have heard a lot about, but it's not enough just to give the robot sort of cameras and sensors as eyes. We need to teach the robot, when you see something, this is what it is. When you see a person, it's a person. When you see an obstacle, it's an obstacle. And so over time, the robot uses this artificial intelligence capabilities to become smarter and recognize those things. And then also we use algorithms for things like navigating, path planning, controlling, which essentially just means how do we make sure the robot is effectively able to control its tracks, control its motions, so that it can do the work that it needs to do and get around the job site. So unless there are any questions there, we can go ahead and move over to the next page. Okay, so it looks like. Yep, it looks like there are a couple of questions coming in here. First from Ernesto, he asked, how often are software updates made for your robots? Great question. So, I mean, this will vary from company to company, but for a company like ours, because, you know, we're a very young, very fast moving company, we make software updates sort of all the time. A big part of our company, right, or most of the people that are working at our company right now, or a big chunk of them are software engineers, and they're working every day to make improvements. You know, the robot will be out in the field, we'll be monitoring the progress, and we'll, you know, identify opportunities to make improvements to the robot software, and we'll do those sort of on an ongoing basis. And then the second question from Miguel is, so Built Robotics is more of a software company than a hardware company, since you're integrating your work into pre-built hardware. Yeah, I think that would be right to say. For sure, we feel that in terms of, you know, technology that we're developing, the software is really the key component, right? So we don't actually manufacture any hardware. So obviously, like I mentioned, on the construction equipment side, we work with equipment that's already out there. But also for the computer, the sensors, the GPS, we have a suite of partners that we work with who it's sort of their mission to develop really good sensors and really good GPS. And we work with them, put them into a kit. That's not to say that side of the house isn't important. It's extremely important to make sure we're identifying the right products, the right sensor, and all of those that work specifically well for this type of use case. So that is a very important component of it, and it is a big part of what we do. But in terms of what we develop, the proprietary technology that we're focused on developing at our company, certainly sort of the big part of that is software.
We have one more question someone sent me privately, and I think you're going to touch on it in a little bit, but
Sure.
They're wondering, how complicated are the robots? Do you control them with a controller, or do you program it every time?
Yeah, that's a great question. Yeah, we will get into that a little bit. But in terms of, I'm not sure how to answer the question, how complicated are the robots? But yeah, so you are not controlling the robot sort of everything that it does, right? So while we do have the capability on the computer program to control motions of the robot if you need to. So let's say you wanted to pause the robot and back it up a little bit and move it forward. We have that capability using the keyboard on the computer. But for the most part, we give the robot a set of instructions. So let's say we know for the next 5 hours, we want the robot just to dig from a straight line from this point to this point. Then you would input those instructions, you know, where I want you to start digging, how wide I want you to dig, how deep I want you to dig, where do I want you to put the dirt that you dig, and then I'll let it run, and the robot will sort of, you can go to sleep, you can turn around, do whatever you need to do, and the robot will keep working for that stretch of time. But yeah, we'll definitely get to see a look of how that works once we jump into the videos. So we'll actually just keep moving on here. Please keep adding the questions, but maybe just to clear this next page here, which I know a lot of people will be interested in, is the safety system. And so this is something that we want to share quite a bit about, because this is something, you know, it's probably it is our top priority as a company, making sure above all else, we're developing these robots and everything about them to make sure they operate safely, and we have all the fail safes needed to ensure that 100% of the time the robots are operating, we know that they can operate safely. And so that means a couple of things for us. That means developing and putting in places things for people to see on job sites to make sure they're aware that what they're seeing is a robot, and they know that it's an autonomous piece of equipment that's working. And also some technology components that we built into the robot's capabilities to make the robot work safely, sort of, you know, by nature. And so the first side of those things that I mentioned, which, you know, helps people understand sort of the environment and the fact that robots are working there, is what you see on the left side of this page here, which is some lights and sounds that we develop into the machine that are specific to autonomous operations. That once people are made aware of those things, they know, oh, if this light is on or if this sound is coming up, we know that robot is working, it's working autonomously, and sort of I should be aware of that while I'm around the robot. And then the second thing that we also set up is a physical barrier and signage. So that's just a temporary barrier that we set up around the robot just to sort of delineate the area that the robot's working in, so everyone's aware where the robot is working, and also signage just in case, you know, people are walking around and they may not be familiar. We let them know that the robots are working there. And then the second thing is the capabilities that we built into the robot itself. And so the first part of that, what you see in layer one there, is what we call the sense and avoid or perception capability. And that's using those sensors that we mentioned that we install into the robot that allow the robot to see things, see people, identify people, and know if a person gets too close, it needs to stop working just to make sure everything is safe. The second thing is sort of ties hand in hand with the physical barrier that I mentioned, which is a geofence. And now you can think of this as a digital fence that we program into the robot so that we tell the robot, hey, this is your work area. You shouldn't exceed there. So just stay in here while you do your work. And that way we know as long as people stay outside of the safety barrier and the robot stays within the geofence, we sort of safely kept those people and robots apart. And the final thing is an e-stop, which is short for emergency stop button. And this is something that we keep on hand, both wireless for people and then wired on the robot. And that's a button that you can push at any time and it'll just immediately turn the machine off. And that's, in case for whatever reason you feel something's unsafe or someone's watching the robot and feels like we need to just stop working for a little bit, you can just push that button and stop the robot there. So if we go to the next page here, we'll talk a little bit about the role of a robot. And so this is a little bit sort of to the question earlier about sort of how do robots integrate with people? How do robots affect sort of the job industry? And so just to echo a little bit of what Derek was mentioning earlier, the way we view robots, while of course they are doing a lot of the tasks that people are currently doing, is really that robots will function as an aid to people and not a replacement of people. And this is due to a couple of different reasons. One, first of all, is that, really the way we think about it is that right now we need all the help we can get. We need all the people we can get in this industry, right? We saw on that one page earlier, there's a huge backlog of projects that need to be completed. There's a huge gap in the amount of people that are able to do these roles compared to the people that are entering the industry. And so we need robots to help the people that work in the industry work more efficiently and work more safely. And so it's really all about having the people that do work in the industry get more work done or get as much work done as possible for the hours that they spend working. And so that's really the key mission. In terms of roles and how we think about different tasks being split up, if you think about the best thing for robots to be working on, what robots are best suited to do, it's not everything under the sun. It's not every job that people are doing right now on construction sites. It's really your most simplistic, your most repetitive tasks that robots are really good at. The thing that people like you or I might feel boring, where I'm just doing the same thing over and over again for hours and hours and hours. Robots are actually really, really good at that because we can just program them to do something and say, hey, just do this one thing for 10 hours, and they don't feel bored, right? They don't get tired. They just do that same thing over and over and over again. And so that's what they really excel at. But of course, that's not indicative of everything on a construction project, right? There are many things that require a lot more skill, a lot more thinking, a lot more nuance. And of course, we need people to continue doing all of those things. And then finally, of course, what we'll touch on a little bit in the career section is that there's still people needed on job sites to manage the robots. And so it's not like you can just sort of plop a robot on the ground on a construction site and sort of have it figure everything out. People need to figure out where the robot needs to be working, what it needs to be doing, and how to move it from place to place. And so that will be a key role moving forward. So I guess the net of it is, in no way will there be, or are we trying to set up a job site where there's no people and just robots running around everywhere? It's really about how do we use robots as sort of an amplifier for people, and how do we get robots and people to work well together to get the projects done more efficiently and more safely. So before we go into the video, I will get into some of the questions here. Couple of questions here. So the first one is from Colin. So the robots act similar to CNC machining technologies. I'm going to be quite honest, I'm not too familiar with CNC machining technologies. So anyone else in the group is?
Yeah, I'm more than happy to jump in here. So basically, yeah, I think that's a great analogy for what we're doing. So CNC, for folks who are less familiar, it's it's a machine that's very commonly used in manufacturing. And so you kind of use some software to program what you want the machine to create, and then the CNC machine can kind of cut that into the piece of metal or whatever you're working on. Similarly, if you think of construction as outdoor manufacturing, we're doing the exact same thing. So we're telling the robot, hey, I want this is the design, or this is the construction plans of what I need built. You provide those inputs, and then the robot will match those inputs and produce that in the earth. So I think that's a great way to think about what we're doing as far as like outdoor manufacturing is concerned.
Great, thanks, Gaurav. And then the next question here from Cobb is there any possibility of the robot disobeying commands and going rogue? It's a great question. I guess you're thinking about maybe the movie I, Robot from back in the day, or a number of other robots. But the short answer, I think it's a great thing to be worried about. Great thing that, as people who work in the industry, we need to be cognizant of. But yeah, as far as our robots go, the simple answer is no. There is no possibility of doing that. The robot can only sort of do the work that we instruct it to do. We're very prescriptive of where the robot works, where the robot digs, where it dumps the dirt. And so the robot is capable only of doing the work that it's been prescribed to do. But yeah, no, definitely a great question.
Yeah, and on that, their software is not called Skynet, so there'll be no impact like the Terminator.
Sure.
So with that, we got a video. We'll pop open. And this is going to be the user interface. And Jimmy, go ahead.
Yeah, so maybe before we play that, just to set this up. Yeah, so that's exactly right. So this is the user interface for our robots. So the way you can think about it is, like I mentioned, we need people, right? And people are the ones that give the robot instructions and things like that. And the way we do that at our company is, using a laptop or a computer, you access this program that we develop at our company, and you log in and you connect to the robots, and that's where you give the robot instructions and monitor the robot. So we'll go through that here. So if we start playing that video, you will pretty much see step-by-step how this works. So similar to a lot of things, you'll just log in. And once you do that, you're going to want to find the robot that you want to operate. And so let's say this is the scan, and you find Rick. And you want to tell Rick where you want it to work. So you picked a geofence and selected it, and you run a couple of safety checks, and now you're connecting to the robot. And so you found your robot, you told your robot where you wanted to work, and now you're conducting some connection and safety checks. So now you connected to the robot, and you've launched our program. And so now you want to tell the robot what you want it to do. So let's say you want it to excavate a foundation, and it's a particular type of foundation, in which case A13 is just a specific dimension and specifications for the type of foundation. And that's where you want it to dig, how big, how deep, if you want to dig a ramp in, and all those things. And once you hit start, this is sort of what happens. The robot will start digging digitally. There will be camera feeds going up where you could see what the robot's doing from multiple different angles. And you can also monitor sort of the status of the robot. So it's network connection, it's engine levels, it's temperature levels, it's fuel levels, it's computer temperature levels, and all of those things. And you can keep an eye on all of that through this interface. So that's essentially what it would look like if you were the person in charge of working this robot. You would set it up in the morning, maybe making sure it has the fuel and greasing and everything that it needs. And then you would go back to a truck or wherever else. You would open up your laptop, and this is exactly what you would see once you start opening up your laptop screen and logging in.
It might be a good time to do a quick pause to see if anybody has any questions while we have the user interface up. We can always come back.
That is a great, so the question Paulette asked is how many cameras are on the robot? This number is changing a little bit. Garb, do you have the latest number on that?
Yeah, we have about 5 cameras on the robot now. And so they're arranged in a way that you get 360-degree coverage. As you can see in the interface here, the 2 big windows are 2 of the views, but then you can choose other views at the bottom there. So there are 5 cameras, and then there's a 6th view just to give you a bit of a redundancy.
We just got another question from Iris. She asked, so is there a consulting aspect to this job, like getting and implementing feedback from the client to improve the software? Yeah, no, that's a great question. So we don't have any quote unquote consultants working at our company, but there is a sort of part of the company and part of the way we work with our customers and our partners like Mortenson, that is a lot of what you described, where the robot will be on the ground for a project, working with one of our partners, and certainly we'll get feedback from pretty much every day from both our internal people who might be near the robot, and also our customers who will know the robot behaved a certain way. Maybe this can be improved, and maybe this feature can be added. And of course, we'll take those back to our engineering teams and they'll figure out a way that we can make those improvements.
Perfect. Maybe we jump to the next video, Jimmy.
Sure. Yeah. And this is just a quick video. We wanted to show you, of course, we showed you that video earlier on, which was multiple different angles and things like that. And we just wanted to show you a very sort of, in person, like what would it look like if you're on the ground, sort of first person point of view, looking at the robot digging. And so it's just a quick clip that shows the robot working. And so yeah, what you'll see here, you'll see it a little bit here, but once we see the cab, you'll see there's no one in the cab of the machine. There's no one sort of controlling it from a computer. This is just what it looks like after you've given the robot instructions. You push start, the robot will start working. So that would be the point where we told the robot to start digging, and the robot will take its first scoop. Here in this case, we told the robot to dump the dirt to the right side of the trench, and so you'll see that's what it did. And then it'll just keep on doing that and keep on digging until it's dug the trench that we've told that robot to dig. And so you see there those blue lights blinking on top. Yeah, the robot will just keep on repeating this digging motion until it's time to back up and continue digging to finish up that trench.
And going back to some of those, that solar photo, on a solar job, we have to dig a lot of these trenches, roughly about the same size of this, where we'll have to bury the wire underground underneath those solar panels, so that we're able to then connect all those panels together so we can transport that power. So that strip could be anywhere from a couple hundred feet or 100 feet to a couple hundred feet or even thousands, just a straight line.
That's right.
So any questions on that video or the previous video? Looks like we got one.
So Paulette asks, are the machines the same exact models that are used with people operated machines? Can these be operated as a robot and a traditional machine? Yeah, that's a great question. So yeah, the robot, yeah, for us, all the machines that we work with and all the ones that you saw in these videos are machines that traditionally people would use. So they're the exact machine that people would buy just to use with normally people operated, and we've just upgraded them with those kits that you saw and essentially turned them into robots. And the second part of your question, can these be operated as a robot and a traditional machine? Yes, actually, that's a great question, and actually an important question for the business implications of it. But yes, so we can operate them robotically and autonomously, as you saw. But if for whatever reason you need to do something that right now is not maybe a great fit for robots, or maybe we need to do something that requires a little bit more finesse and a little bit more detail, someone could jump into it the same way you would do before it became a robot, and just turn off all the robotic components and just use the joysticks as you normally would. So yeah, absolutely. The second question, or the next question here from Colin, he asks, how precise of work can the robots do compared to human operators? That's a great question. And the simple way to answer that is the robots are quite precise and quite accurate when they do their work. When you think about robots, they're actually really good at that type of thing, where if you wanted a robot, let's say, to follow a straight line, robots are very good at that, because we use GPS and a couple of different technologies to make sure that the robots can only dig in the way that we tell the robots to dig. So if we say we want you to dig in a straight line from point A to point B, the robot can't actually do anything else, because that's how we programmed it to do. With that said, of course, there are, of course, great operators in the world, people who have been operating excavators for 30, 40, 50 years. And those people will always have sort of tricks up their sleeves and sort of experience that will allow them to do work a little bit faster, maybe some different little tricks that they've come up with over the years that'll make them be more effective than some of our robots.
So that might be a good transition into the careers, Jimmy.
Sure.
I do have one more question. Someone sent me privately. Can the robot draw something in the ground?
The robot could. That's not a core thing that we are working on right now. But yeah, certainly the robot could draw something on the ground, right? So all that would be is a programming of the robot to take its excavator, instead of digging in a straight line. Maybe it would be a straight line from this point to this point, and then maybe a circular motion and align to the left or right. So yeah, certainly we could program the robot to do something like that. But yeah, not something we are too focused on doing right now. Great. Well, yeah, unless there's anything else, what we were hoping to do is talk a little bit about what we see as careers, both right now that exist and might come about in the future as robotics in construction starts to grow and starts to scale in the way that we think it will. And so we bucketed sort of three sort of categories of roles. This, of course, in no way exhaustive, but some of a few that we think will be really exciting and might be something that might be interesting to some of you on this call. First is the role of being the person that builds the robots. And so this is, of course, a role or a couple of roles that we have a lot of at our company, but these are engineering jobs, right? So either robotics or software engineers. Your role would be being the person that builds the robots, right? Either on the hardware side or the software side or whatever in between, making the robots smart. Maybe we need to develop a new robot, and that's what you might do, or making improvements to the robot either on the software side or whatever else. And that would be sort of your day-to-day job. And so if you're someone that maybe you get really excited about working with your hands and you want to be really hands-on, maybe you're excited about studying computer science in the future. Maybe you join the robotics team at your school. This might be something that's really exciting because it can be really fulfilling for a lot of people to join these roles where they feel like they're part of building a new technology that's going to be used out in the real world.
And then the other one's operating the robots. So on the Mortenson side, we need to be able to have operators, and whether they're operating a piece of equipment manually or they're a remote equipment operator where they're operating different autonomous robots. And that could be just a one-to-one where you have an operator managing one fully autonomous robot. They could be managing a fleet of 2 or 3, or in theory, we could have an operator working with 2 or 1 fully autonomous robots while they're also in a full manual piece of equipment performing work. It allows us to be flexible. It allows us to be able to perform much more work at one time. And then obviously managing the robots. We'll have to set up some sort of dispatch system where we're managing where all of our fully autonomous robots are, what projects they're at, when they need to be there. And with our work in renewable energy, the wind and solar farms, we're doing work all around the country. So we need to be able to have the flexibility to send these pieces of equipment to those different aspects as soon as jobs are starting up.
That's great. And then maybe just to clear the page before we get into the questions, yeah, thinking about, in the future, as we think about more and more robots come in the field, yeah, like sort of like Derek mentioned, we'll need people not only to operate the robots, but also manage them and make sure, they're going in the right places, doing the right work, assign the right responsibilities, so on and so forth. And so while this might be a little bit more of a limited role right now, where we've only got, so it's sort of the start of this transformation and innovation entering construction, and there's only a handful of robots sort of out in the field at any given time for any given company. If you think about in the future, if there's dozens and potentially hundreds or maybe thousands of robots, there will be a key role to make sure robots are deployed where they should be deployed, doing the right type of work, and assign the right instructions. So that is all the material that we've got prepared for you all today. Yeah, we'd love to take questions. I see a couple have come in here, so I'll just start taking them. Colin asks, are there any specific engineering focuses that would be better suited for building robots? For example, mechanical engineers. Yeah, that's a great question. I think, a couple of different majors, maybe that's what you think about potentially in college, different majors and what you might study in engineering would be really, really well suited to robotics. I think mechanical engineering would be great, understanding the mechanics and how robots work. A lot of people at our company have studied computer science because that's a big part of, writing the software and building the software that make their robots, work well and work efficiently. And then, I'm very sorry, but if I pronounce this wrong, but it looks like Ansh Kumar asks, are there any specific languages used on the software side? Garb, did you want to take that one?
Sure. Yeah. So we do most of our work in Python. So that's a good language to learn, and it's commonly used, I think, in a lot of technology these days. And being, I guess, a little more specific to the robotics side, we use something called ROS, which is the Robotics Operating System, which is a pretty standard operating system for robotics. And so that has some of the basic stuff already pre-built, and then we build on top of that platform to build all of our features. So those are a couple of things to look at. Yeah, Python would be the language to answer your question.
And Gaurav and Jimmy, isn't it true too, to follow up on the education focus and which engineering really lends itself to robotics? I mean, wouldn't you say that the undergrad degree or the first 4-year college degree, typically will be in something broader like mechanical or like electrical or computer science. And then with each level from master's towards PhD, it gets more and more specific to robotics and autonomy and machine learning.
Yeah, that's absolutely right. So yeah, I think the kind of three that we most commonly see at Built are mechanical engineering, as Jimmy mentioned, electrical engineering. One of our co-founders, actually, Andrew, he's an electrical engineer from Caltech, and he's done a lot of other work. He worked at NASA, and then he worked on drones before he helped found Built Robotics. And then computer science is the other big piece. A lot of Built Robotics folks, we have kind of a good blend of folks who just do undergraduate degrees. So they have a bachelor's of science, 4-year degree. But then we have a handful of folks who went on to do graduate work and have a master's or a PhD as well. But it's not a requirement. So we kind of look across the board, and really what it comes down to is, people who are problem solvers, they have really solid basics. They've learned physics and, electrical, and then obviously basic programming, or, above basic programming on the software side. But it's more about what you've done. Have you built something? Have you, solved a big, tough problem, and how did you address that? Those are the skills we really care about. And a lot of the 4-year institutions are really good at giving you that solid foundation to build on that. The other point I'll make is the engineers are really important for building the robots, right? There's another piece of this, which is when the robots are out there, there's management, but there's also how to repair robots in the field, right? So there's a whole other class of jobs there, which is if you're really good with your hands and tools, there's almost like more of a trade work that emerges there on how do you maintain a robot. So today there are a lot of diesel mechanics who are good at maintaining excavators, but who's the mechanic that maintains an autonomous excavator? So, if your computer goes down or your sensors go down, there's going to be someone who really needs to understand how that system works, how to fix it, how to install it on the machine in the first place. And so there's, I think, technicians that we'll also need to have who kind of manage these fleets of robots and help kind of repair them and install them and upgrade them. So I think there's all kinds of opportunity out there. If you find yourself really excited about engineering, then I think there's a bunch of stuff you could do there. But if you find yourself, you really love time in the field and you really want to be on the job site, you could find yourself doing some of that work on the robotics side.
It looks like we're coming up on time, Paul. Is there a hard stop, or?
No, you can definitely finish this. Yep, there's a couple more questions, I'm sure. Yeah, it'd be great.
Looks like a couple more might have come for the Built team.
Yeah, I'm happy to take a crack at these. So let's start with Joanne's question about mechatronic engineering. Yeah, that's another good one. Mechatronics is sort of a blend of mechanical and electronic or electrical engineering. So yeah, we have someone actually on our team. She's based in Australia. She's a mechatronics engineer, and that's another great fit for what we do. And Colin's question, for the benefit of the broader group, I think Eric already answered it in the chat, but FIRST Robotics is a great great experience that could apply to robotics. There are a lot of programs out there if you're interested in robotics, especially at the high school pre-collegiate level. I know there are a lot of groups out there that you can get involved in, and I think that's the most important thing. You can learn a lot from the books, but then you also need to go out there and apply what you've learned. So go do a project and go try to build something yourself, because I think that's where you get a lot of really good experience, and that's what we do every day in our jobs. And then Miguel asked if where we're located and if we're looking for any interns. So yeah, I love to hear that. We're located in San Francisco, in the city here in California, and we do take interns. I think generally over the summer we take some engineering interns. So if you're in, but typically only in college. So once you're in college and you're on your way, definitely reach out. We would love to hear from you, and yeah, it'd be great to work together if you're looking for a summer internship.
I'm glad that question came up. Well, we are convincing more and more of our companies to take high school interns. So if you ever want to change your mind, I'm sure you've got a lot of kids that will be knocking on your door.
Definitely, we would love to start a program like that too.
Eric, on the Mortenson side, what's our programs look like?
Similar to what Gaurav was describing for Build. We have a really pretty detailed and pretty formalized internship program. A lot of civil engineers and construction management. To people who are in college at that time or who are our interns, but not too much for us on the high school side, other than what we're doing with, like Mortenson thinks just the world of ACE mentors and the work that ACE is doing in the country and in high schools. And like we're a huge proponent, a big fan, and try to be a big help of the program. But most of our formalized internship is also college.
And I will say that, Mortenson is far and away one of the most innovative companies we've met in the construction space. And so, and we've gotten to know a lot of folks who work there across all sort of levels and backgrounds. So highly, highly recommend. I think it's a great environment for young people to learn and grow. I've seen it with my own eyes. So highly, very appreciative that we get to work with Mortenson, and I'd recommend everyone taking a hard look at them when you're out there.
Looks like there's one more question about internships.
I can take that. A quick follow-up to Colin's question here. That's not a requirement for Mortenson. We take many college interns who have just completed their first year on up to right before their senior year. We do a big thing that's like the internship movie with, like Owen Wilson and Vince Vaughn. They do a bunch of fun activities, but the first and second and third years don't get to do that. Only until their fourth year they get to do that.
Yeah, we don't really have any hard requirements at Built. We encourage, people to reach out, and I'll quote Hamilton on this one: just shoot your shot, doesn't hurt. Send us an email if you're interested. Let's start the conversation. And if it's not a great time right now, we'll find a good time later. But I think we would love to hear from you. And if you're interested, definitely shoot us an email. Let's talk. And then, yeah, we'll figure something out.
Great. Well, you guys, thank you so much. This was, great. I can see there's lots of jobs for lots of people coming up in the future. You did a great job on showing that there's anything it looks like that you want to go into in this industry will be available soon and needing people. So this is a great audience for that. So hopefully everyone listened in on that. And if you guys have any more final remarks for our group before we log off here.
No, I just want to say thanks, Paulette. Thanks everyone for joining. It was really great privilege for us to join, and we really enjoyed chatting with you all.
Yeah, thank you. Thank you. We definitely enjoyed it very much. Again, we're always looking for any kind of opportunities that you want to share with us. So just watching that little bit of that excavator, you know, the little tiny screens, it was very exciting. So I know we are definitely interested in learning more.
Yeah, really good audience and great questions. Thank you so much for all the audience participation and the engagement. That was just great.
Yep. Yeah, we have some really good questions that come in on these. It's been really fun. And I got to answer. Well, I do have one more question. That the farm in California, where is that? It looks very familiar to different, parts of California I've driven in. Do you know? Or can you say?
Well, so that the photo there wasn't from that job because that job hasn't started yet.
Oh yeah, of course, that makes sense. That makes sense. But yes, I've seen lots of farms like that up and down in the space in California where there's lots of open space out here. It's great. All right, you guys, well, thank you so much. I'm sure we'll be seeing you again and talking with you soon. Let me know if you need anything from us. We're here, to support you as well. So again, thank you very much. And thanks everybody for logging in today.
Appreciate it. Thanks, everybody.
Bye, everyone.